Hey there, data enthusiasts! Welcome back to our channel, where we dive deep into the fascinating world of data science and machine learning. Today, we're going to explore an incredibly powerful tool in the realm of model explainability, SHAP. If you've ever wondered how to make sense of those complex machine learning models, you're in the right place. So, let's get started. But first, let me ask you a question. Have you ever used a machine learning model and found it hard to understand why it made a certain prediction? You're not alone. This is a common issue that data scientists face. That's where SHAP comes in. So, what exactly is SHAP, and how does it help us explain our models? Let's break it down. SHAP stands for S-happily additive explanations. It's based on concepts from cooperative game theory, specifically the Shapley value, which was introduced by Lloyd Shapley in the 1950s. The core idea is to fairly distribute the payout of a game among players based on their contribution to the total payout. In the context of machine learning, SHAP assigns each feature of a model a value that represents its contribution to the prediction. Now, let's understand it with a simple example. Imagine you've built a machine learning model to predict house prices based on various features, size, location, number of bedrooms, and so on. When the model predicts that a house will sell for $300,000, SHAP helps us determine how much each feature contributed to that prediction. For instance, maybe the size of the house contributed $150,000, the location contributed $100,000, and the number of bedrooms contributed $50,000. With SHAP, you not only get the final prediction but also insights into how each feature influenced that prediction. Now, let's take a closer look at the mechanics of SHAP. SHAP values are calculated by considering every possible combination of features to determine their contribution. This might sound computationally intensive, and it can be, especially with a large number of features. However, there are optimized algorithms, like kernel SHAP and tree SHAP, that make these calculations much more efficient. For example, tree SHAP is specifically designed for tree-based models like decision trees, random forests, and gradient boosting machines. It calculates SHAP values in linear time relative to the number of leaves in the tree, making it incredibly fast and efficient. This is a game changer for data scientists who are often pressed for time and need quick insights. Now, why is SHAP so important? In today's world, transparency and interpretability in machine learning models are crucial, especially in sectors like finance, healthcare, and law, where decisions can have significant consequences. By using SHAP, we can provide stakeholders with clear explanations of how predictions are made, which builds trust in the model. Let's look at a real-world application. Suppose a bank uses a machine learning model to determine whether to approve a loan application. If a loan is denied, the bank must provide a reason. Using SHAP, they can explain that the applicant's credit score had a negative contribution to the prediction, while their income had a positive contribution. This not only helps the applicant understand the decision, but also allows the bank to comply with regulations regarding fairness and transparency. Another example can be found in healthcare. Imagine a model predicting the likelihood of a patient developing a certain condition. By applying SHAP, physicians can see not just the risk score but also which factors, like age, weight, and family history, are most influential. This information allows for better patient communication and more tailored treatment plans. As you can see, SHAP is not just an academic concept, it has tangible applications that enhance our understanding of machine learning models. But it's also worth noting that SHAP values are not without their limitations. They do assume that the model is linear, which may not always be the case, and can sometimes lead to misleading interpretations if not used thoughtfully. It's crucial to combine SHAP with domain knowledge to draw the right conclusions. So, to wrap it up, SHAP is a powerful tool that provides insights into machine learning models by explaining the contribution of each feature to a prediction. It fosters transparency and trust, paving the way for better decision-making in various fields. If you're not already using SHAP in your projects, I highly encourage you to give it a try. It can transform the way you communicate your model's insights. If you found this video helpful, please give it a thumbs up and subscribe for more educational content. And don't forget to hit that notification bell so you never miss an update. Have questions or want to share your experiences with SHAP? Leave a comment below, we love hearing from you. Thanks for watching, and see you in the next video.